So today we're going to continue with chapter 5. We're going to backtrack a little bit and discuss the idea of counters. Counters, as we discussed in class prior, are variables that are incremented or decremented each time the loop repeats or iterates. The counter itself can be used to control the execution of a loop. So a counter can also be a loop control variable. These two are technically two different purposes. They're both still variables, usually integers. They're still variables that you create with a specific purpose. The purpose can be either to be a counter, a loop control variable, or they can be both. Most of these values should be initialized before entering the loop, and it makes sense because if you have a control variable that has no value, that has the value null, then you end up in a situation where the loop will never execute. Or you might have a situation where the loop doesn't really have a way to keeping track of how many iterations has it gone through. And these control variables or counters can also be incremented or decremented inside the loop or in the loop test itself. Most of the cases, at least for the variants that we've discussed, which is a while loop, and the next one would be the do while loop, these counters will have to be increased inside of the loop itself, inside of the structure of the loop, after the test, within the curly braces, or if it's the case of a for loop, then that variable will be increased in the test itself. This is an example of a counter where you declare a variable called integer myCounter, and you assign the initial value of 1. This is where the counter itself is declared. Then you have a while loop. The while counter is less than or equal to 5. Do some stuff and increase myCounter by 1 by doing this plus plus right here. This is what keeps the loop in control, pushing it closer and closer to be 1, 2, 3, 4, 5. Once the counter reaches 6, then the while loop can exit, and we can proceed to the next task, which would be somewhere around this area. This is just to exemplify that this is the structure of a while loop. There might be some stuff happening here where it says do stuff. There might be some calculations being performed, or some prompts being performed to prompt the user to enter some data. And then the counter itself is the last thing that happens, because you don't want to increase a counter up until the end. That's when you push the loop to the next iteration. There is a possibility that you do not know the number of executions that the loop will require. So you can actually set up the variable to be initialized by the user. Instead of us setting up integer myCounter equals 1, we can ask the user to initialize it. We can also ask the user to set up how many iterations they want to execute. Instead of having this to be a static number of 5, we can tell the user how many times should this loop repeat, and the user will enter whatever value they think is necessary. So the program can be written so that the user input determines the loop repetition. It can be used when the program processes a list of items and the user knows the number of items that will be performed or that will be processed. It might be that we don't know that. We can't set it up as a static value on the loop, but the user will know at any given time. Say the user knows that he or she needs to process a list of 125 items, then the user can enter that value. The user is prompted before the loop. Their input is also used to control the number of repetitions. This is very important because we want to set up that control. We want to set up our control variable and the limit or the number of repetitions that the loop will execute before the loop executes, because we want to have those parameters set before we configure the loop. This is an example where the user will control the loop. Integer num and limit. Num will be a counter, and limit will be the number of executions, the maximum number of repetitions that the loop will take. Cout, table of squares. Cout, how high to go. Cin, we capture the limit. This is the value that will allow us to set up how many executions the loop will take. And then Cout, number square. Number equals 1. Number was already created here. This is the initial number for that loop. While num is less than or equal to limit, Cout, and then we format our numbers, we format our output. So basically what this number is doing is the number of squares for a specific number that we configured. This value right here that is being placed on limit, when the user sets it up and enters a value, that's what's going to be used as the number of repetitions for that loop. Instead of us hard coding a 5 or a 6 or a 10, the user will tell us how many times the loop will repeat. We have a hands-on program which will be Lab 6. You will create a program to loop and display to the user the counter. You will use a while loop, use one integer variable to store the limit and one to store the actual counter. The user will be prompted for the limit itself. Display to the user, this is counter n, so that we have an actual count of how many times the loop has executed. And remember that this will be worth points. It'll be a lab. So the lab will consist in creating a program to loop and display to the user the counter. We're going to use a while loop, and we're going to use a variable to store the limit and one to store the actual counter. The counter is the one that will be increased. The limit is going to be the variable that the user will enter in order to set up the maximum number of executions for that loop. So we already have my two variables here, integer counter equals 1 and limit. Limit will be initialized by the user. So I'm going to Cout. Please enter. Apologies for the squeaking. My dog decided to play right now, right next to where I'm recording. Please enter the limit for loop. And then we're going to capture using Cin the limit. So now limit will also be initialized. So we're going to do a while loop while counter is less than or equal than limit. Then we execute. And the program's asking us to display this is counter n. So we're going to say Cout. This is counter. And then the last thing, as I mentioned on the previous slide, the last thing we do when we're dealing with loops, the last thing we want to do, or we want to make sure that at some point in the loop is the increment of that counter variable. I can save this, and I'm going to compile it. I'm using my Linux machine, so I can do another command. G++ is the command that we use, and you're going to learn this next week. We're going to go through some videos where you're actually going to run the programs on a Linux terminal. So I'm going to say lab6.cpp -o lab6. I have a return 0 expected. Oh, there's a semicolon missing here. So I can run lab6. Please enter a limit for loop. I'm going to say 5. Let's counter 1, 2, 3, 4, 5. I'm going to clear my screen. Lab6. I'm going to say please enter limit for loop. I'm going to say 12. Displays. So what we're doing here is we set up our counter variable to be equal to 1. We initialize to 1, and then we create a limit variable that will be initialized by the user here. And then we set up our while loop to count or to iterate while counter is less than or equal to limit. Limit was set by the user. If the user enters 1, then the loop will only execute one time. And we make sure that we increment our counter by 1. And this is going to be the lab that will be turned in for today. Remember to make sure that you include the information and the lab information and your name always on top of the program, and review the concept of what a while loop is, how it works, how it can be controlled by the user completely, or we can set it up ourselves. We can change that value into a 10, and it's a 10. The loop will iterate 10 times hard-coded into the program, or we can just set it up as something that the user will control.